The work is about automated deal amount validation in CRM systems using large language models. An IT company focused on selling off-the-shelf solutions to facilitate work with CRM systems that require verification of a salesperson estimate of the transaction value. This meets a business need to ensure the accuracy and reliability of data, as manual verification is time-consuming. It was decided to develop an automated service to check the accuracy of the transaction value entered by the manager. Large language models are best suited for this purpose. So we used LLM and LLM agents. Here is the research and developed algorithm.
I beg
We
your pardon.
detect.
Probably we see the wrong screen now. You are sharing not.
Oh, thank you. I will try to sharing an entire desktop. How about now?
Thanks. That's much better. Thank you.
We are detecting the fact that the deal amount was discussed. Extracted email in which the deal amount and product were discussed with two neighboring emails. Later, there is an analysis of the email for the presence of the product information, like name, quantity, and price. If there is information about the name, quantity, and price of the product, um, of the name and quantity of the product, we search for the closest product in the price list. If there is a price mentioned, then LLM independently calculates the deal value. And if the information about the product is missing, LLM returns a response indicating insufficient information. Later, there is a comparison of the calculated value with what the manager entered, and recommendation and classification of whether the manager's figure is supported by the facts. So the last step is comparing the calculated costs of with one specified by the manager for classification. We used LangChain framework that is widely used to extend the customization capabilities of the LLMs, ensuring the relevance of the generated information. An LLM agent was used to develop an automated service for checking the correctness of the transaction amount entered by the manager. LLM is the underlying technology that provides language capabilities, while LLM agents use this technology to perform specific tasks and functions. So, in general, LLM agent can consist of following main components, like user query, LLM agent slash brain, the core of the agent that acts as coordinator, planning that assists the agent in planning further future actions, and memory that manages the agent's past behavior. Um, During the experiment, two models from OpenAI were used, the GPT 3.5 Turbo and GPT-4, to improve the efficiency of LLM agents. Um, Hint engineering is used to interact with other inputs. These hints describe the tasks that the LLM agent needs to perform and provide the necessary context to generate relevant and high-quality results. Each hint should contain such elements as role that indicate who LLM is supposed to answer, objective, clearly define the expected result, and additional information that will help the LLM to perform the task better. In addition to basic elements, the prompts can also be improved using zero-shot, one-shot, and multiple-shot learning methods. Zero-shot use in which LLM uses its only own knowledge to make decisions and generates the answer based on that. One-shot, the LLM uses one example of how a task is performed to make decisions. Example describes the sequence of step and logic of solving the problem. And with multiple shots, LLM uses multiple examples of how a task is performed to make decisions. So we used such guidelines for training our LLM agent. Later, to validate the LLM's agent performance, 50 deals were selected. Only deals that had been successfully completed within the last 6 months were selected. And for those deals, a dataset was formed with the relevant data, namely deal ID, name, opening date, closing date, amount provided by manager, actual amount at the time of closing, and correspondence. We also used a price list containing the name of the service and its price. And here is an example of LLM agent works on several transactions. On a first transaction, after analyzing the agreement, you can see that the client reports the name and quantity of the desired products that have been approved by the CFO. And the next step is to use a utility to extract a cost of the product and the price list and to calculate the amount. And for this purpose, a semantic search algorithm was used. So if the email contains several names of the product, then we can find the sum of the products. In the next example, to find the final amount for the deal, LLM repeated the steps described in the previous example. And in this email, the client specifies the quantity, name, and price of the desired products. So LLM easily recalculated the transaction amount. And as a result, the number coincide with specified by the manager, which means that the transaction amount is supported by the fact that was discussed in the email. But there can be emails with insufficient information. And in this example, this letter clearly discussed the desired quantity of the products and their price is calculated. Because of this, the LLM agent believed that 1,600, although the manager indicated 5,200 and classified it as value not confirmed, different price discussed. However, if we take into account the amount of information that the LLM agent received, the result is correct. This example shows the importance of quality information that is passed to the LLM agent in order to obtain the desired results. And here is a structure of the project. We have main.py, the files that maintain main module of the program, agent.py with LLM agent, template.py with instructions, and tool.py, a file in which functions are created for use in utilities. So this work demonstrates the practical application of LLMs for automating the validation of deal amount in CRM systems, and by leveraging the contextual reasoning capabilities of models like GPT-4, alongside supporting tools such as semantic search and hint engineering, the proposed system can intelligently analyze sales correspondence, extract product-related data, and cross-verify while limitations remain, particularly in cases of incomplete or ambiguous communication. The integration of LLM agents into CRM pipelines represent a scalable and adaptive solution for enhancing operational efficiency in sales environments. Future improvements could include enriching the input data with additional communication channels and refining prompt engineering to further boost model accuracy.